Using Desmos to enhance algebra instruction from concept to fluency by LaQuanda S. Jackson for the EDSE 6156. Hello, everyone, and welcome to this presentation on how Desmos can transform algebra instruction. Today, we will explore how Desmos supports students in progressing from conceptual understanding to procedural fluency, and this is aligned with the algebra standards. My objective for this presentation includes demonstrating how technology like Desmos supports students in deepening conceptual knowledge and fluency, and how such a technology tool can support teachers instructionally. Today's presentation is centered around the Common Core Algebra Standard, HSA CED A2, which asks students to create and graph equations that model relationships between variables. Or I like to also align the standards with the Georgia K-12 mathematical standards. And this one aligns with AFGR2, which asks students to interpret key features of graphs and functions and relate the graphical representation back to an equation. This standard lays the foundation for algebraic reasoning and advanced problem solving. So why Desmos? Well, Desmos is a free web-based graphing tool that allows students to explore algebraic relationships interactively. By dynamically adjusting variables, students can instantly see how changes will impact their graphs, and they can also receive immediate feedback. It works across many devices such as Chromebooks, iPads, phones, making it ideal for the classroom or even if you were in a remote learning session. So research supports using tools like Desmos in math education. The dynamic visualization helps students connect abstract and concrete ideas, which promotes a deeper understanding. So studies show how technology combined with active learning increases procedural fluency, and immediate feedback sustains motivation and helps students correct errors in real time. This aligns with NCTM's recommendations for technology integration in mathematical instruction. So how does Desmos support this standard? Well, Desmos directly supports my chosen algebraic standard. Students can create equations, then they can use sliders to adjust parameters like the slope and intercept. They observe how the graph changes in real time, which promotes a hypothesis testing and discovery learning. So this ties conceptual understanding tightly to procedural fluency. So this is just a little progression chart to see how we go from the conceptual understanding to procedural fluency. We're going to start out with the concept, look at visual representation. Hopefully students may get that pattern recognition, get into generalizations and the procedural fluency, which helps them overall with problem solving. Now, let's look at this instructional strategy in action. So what I'm going to do is I'm going to go out to the Desmos website and see how we can actually implement Desmos. Okay, so here's how we can implement it. We can assign students to predict what happens when they change the slope or intercept in a linear equation. Then using the Desmos sliders, they test their prediction and reflect on results. So this engages students actually in inquiry-based learning, which overall enhances comprehension. So students are going to first manipulate graphs using sliders, then they discover patterns. Finally, they can write equations, and this follows the current recommendation from mathematical educational research. So I'm out on the Desmos website, and I'm on the Desmos graphing calculator. So what I'm going to do is we're going to assume students are learning about slope. Instead of giving them the formula, I'm going to begin with this graph. So on the teacher side, I would use this to project and show my students how this works, first of all. Then I would allow them to do practice. And eventually I have another side of Desmos that I will let them go on for additional practice and individualization practice. So as I said, instead of giving them the formula, I would begin with this graph. So we're going to watch what happens when I move the slider for A, and students will immediately notice that the line becomes steeper. Then I'll make the slope negative and see if they notice. So let's put this into action. I'm going to actually type in an equation, and my equation is y equals 2x plus 1. And as you can see on the Desmos graphing calculator, it has graphed this particular equation. So now I'm going to play with the slider, because what I want to do is I actually want to be able to go in and change up what we know as educators as the slope and the y-intercept. So I'm going to make the slope be a -2 and see what happens. And I'm also going to change the y-intercept from 1 to 5. Okay. Now, hopefully you notice what happened when I went from my first equation, which is the red line, to the second equation, which is the blue line. You'll notice that my slope is no longer positive. It is now pointing in a negative direction. And my y-intercept also moved up. Okay. So students have the option of playing with this to see what happens as they make different changes. And students eventually will be able to describe the change before they even learn the vocabulary of steep. Only after students build these visual connections do I introduce the slope formula. This sequence moves students from the conceptual understanding to the procedural fluence, which research identifies as essential for them to have a lasting mathematical understanding. So once students understand what slope and y-intercept actually represent, writing equations becomes more meaningful. And then the prediction is a powerful instructional strategy because it requires students to think mathematically before receiving confirmation. So students can get some immediate visual feedback that either confirms or challenges their thinking. Now I'm going to do that by going out to the second side of Desmos. And here, this is a teacher side. This is on learning.amplify.com for educators and students. But on my educator side, I went in and I found an activity that I would like for my students to do. This activity is called Marble Slides, and it deals with lines. So once I get to this activity, I actually can go to my teacher dashboard. And I can assign this to students, okay? Once I assign it to students, it's going to give me a code that students are allowed to put in. I have a little mock class set up already, so that's why when I went to my dashboard, it has automatically put me in for me to see what students would see. So in here, I can actually monitor what my students are doing. I can make it where students are anonymous and you would not know their names. I can set the pace of how they work. I can have it synced whereas I am pulling up the slides, they only stay on the slide that I'm on, and I can pause work for students. As the students are working, I can see what they're doing. I can provide immediate feedback to the students. So this makes it easier for the students. Rather than completing a worksheet, the students actually are interacting with the mathematical concepts. So every student participates because every student submits responses. So now what we're going to do is we're going to kind of go ahead and play with this. So since we're learning about slope and intercept, I'm going to start with the first slide. Hopefully you can see it. And on this slide, okay, I'm waiting on my slide to come up. I'm sorry, one moment. Okay, so my slide is up. So we're going to look at this as a student. What the students are doing in this is, look, we're just going to start with a basic slide just for them to get an understanding of what they're trying to do. So they're trying to get the marble where it goes through and hits all of the targets, which are the stars. So we're going to launch it first, just as a play for them to see. Okay, so you made it work with that one. Now, when you go to the next one, there's actually a line. So you're given an equation, but you must change the equation, which means you may have to change the slope, you may have to change the y-intercept in order for this marble to now be able to hit all those stars. As you can see, this line that this equation represents is not where it's going to hit these stars and hit the target. So I'm going to have to go in here and change some things up. So let's do it. Okay, so I'm now on the red line. I'm still not where I need to be. So therefore, I know that's not going to work. Let me just go back and change my equation up. And let's leave it at 1/2. However, let's see what happens if we change the y-intercept. So instead of it crossing at 1, let's get it to cross at -1 and see if that's low enough. Up, not quite low enough. So as a student, keep playing with it. Not -1, let's try -3 maybe. Oh, -3 may get us there. But what happens when I launch this? It's going to drop and it looks like it might go underneath. So maybe then -3, let's try -2. Oh, that looks like it's right on it. So what happens when I launch? Yes, I hit all of the targets. Okay. So students can guess, but they must understand that changing the slope and intercept does affect the graph. Every adjustment provides immediate visual feedback. So if the marble misses the star, what should we change? Well, we could change either the slope or the y-intercept. Either one would work in this case. And again, I could give students immediate feedback because as the teacher, I could go in and look at their correctness. I could go in and actually send messages to students. Okay. And right now I am on the student side. So I can go in and there's only one student in here, but I could send feedback on this particular slide if I would like, just by clicking the feedback button and giving this student some praise. So in this one, I'm going to say good job. And send that to the student, okay? And students have the option of reading feedback on each slide. So again, this gives immediate feedback, helps with problem solving, it is active learning, and it helps build that conceptual understanding. So students naturally begin to start using the vocabulary after a while because now we're looking at, oh, it's a positive slope, it's a negative slope, it's steeper, it's flatter, and what a y-intercept is. This strengthens the mathematical communication while enforcing concepts, okay? And again, I can see every student's work in real time. So this helps with student progress. This helps me with correct answers. It helps me clear up any common misconceptions that I see. It gets students actively participating, and it also shows me who might need a little bit more intervention, okay? So again, instead of discovering misconceptions after I'm grading papers, I can address it while they're actually doing the instruction or having the instruction. All right, so that is the Desmos practice side. Okay, so I'm going to get back into our presentation. Okay, so here are the resources that I used. I went to the desmos.com calculator. I use the learning.amplify.com home side for the educator, the teacher. And then I also showed you the student side with student.amplify.com.join. So once you get classes set up, you can actually have students in there and it makes it a whole lot easier. Or you can just give students a code as you choose your activity. The activities have codes on it that you can share with students so that they can join that way. So to summarize, I want to say this first of all. So Desmo encourages the productive mathematical conversations that we want. Students can explain their reasoning instead of simply reporting answers. So, but understand, technology should never replace quality instruction. Instead, Desmo enhances the effective technology by making students' thinking visible. So it supports inquiry, it supports discussion, it supports giving immediate feedback and differentiation while helping students develop conceptual understanding that leads to procedural fluency. So Desmos is an excellent tool to support algebra instruction by helping students build conceptual understanding and procedural influence. Its interactive features promote inquiry and active learning with immediate feedback, enhancing the learning process. Accessibility is very accessible and easy to integrate. It aligns perfectly with the standards and instructional best practices that are supported by research. And so here are a couple of references of researchers or people who have done studies on the effect of being able to use interactive learning, using technology in instruction. And I want to thank you for joining this presentation on Desmos and algebra. I hope you are inspired to use this tool to enrich your students' learning experience. And please feel free to contact me with any questions or just to share your thoughts. My email address is listed here on this slide. Thank you. Have a great day.